Okay, so chapter 3 is acute angle trigonometry. Okay, so acute angle being a small little angle, less than 90 degrees.
Brody, if you were an angle, you'd be acute.
Okay, so that's what we're getting into now. We use applications of triangles for a lot of things. Triangles are the strongest structural shape. Okay, so we use triangles for a lot of buildings and structures and kind of things. We also can calculate like the weight of signs hanging using properties of trigonometry, so SOHCAHTOA, using like the weight of the sign and stuff like that. So we can use triangles to apply like sciences to make sure that if we are hanging a sign, right, we got to make sure that the cables that is going to support the sign are strong enough, right? And we can solve problems like that using SOHCAHTOA. Also, we can use triangulation to locate cell phones, right? So if you guys ever watch like any crime TV shows or anything like that, when they're trying to locate the criminal, you know, you'll see them like using the computers and they're like, where is he, right? They're using the information that is being produced from different cell towers around the area, right? And then they will essentially triangulate between the three where we have like overlapping regions between them. And then we can pinpoint the actual location of that. Okay, obviously there's going to be like some sources of error in there. You're not going to be able to tell like your true location just from that, but it will give you a pretty good idea. So that's pretty nifty. Okay, so up until now, the trigonometry you have covered has dealt with only right-angled triangles. Okay, so right-angled triangles would look something like this. Okay, and we can use SOHCAHTOA and the Pythagorean theorem to help us solve these questions, right? And then tomorrow when we cover the sine law, this is actually going to allow us to solve triangles that are not right-angled triangles. Okay, so it's kind of nice. So if it was something like this, okay, and these angles are not the same. If we know a side length and an angle, we can calculate angles or side lengths based on the information that's given. Okay, so it does not necessarily have to be a right angle triangle for us to solve it, which is nice. Okay, but today we are just reviewing our SOHCAHTOA and solving right angle triangles, okay? So labeling review, so label a triangle ABC. Okay, so C is going to be our hypotenuse, okay? And then A and B are just going to be our other two side lengths. Okay, it does not really matter what side you say is A or B, okay, as long as you have the hypotenuse being your C. Okay, why is that?
Because it's the biggest side.
Because it is the biggest side for sure. And does anybody remember the Pythagorean theorem?
A squared plus B squared equals C squared.
Exactly, okay, perfect. So A squared plus B squared is equal to C squared. And that's exactly related to what Logan had mentioned, that
They just have that.
the hypotenuse must be the longest side, right? Yeah, for sure. Okay, good. So that is the pattern that Pythagoras did discover. Very good. Okay, so we are going to apply the Pythagorean theorem and also our knowledge of SOHCAHTOA. Okay, and I'm just going to write this down again on here. So we have SOHCAHTOA. If you're like, what is SOHCAHTOA? This is just like the ratios between sines, cosines, and tangents, and varying sides of our triangles, right? We have opposite, which is always going to be opposite to the angle in question, okay, and not the right angle, okay? So if we know this angle right here, okay, we'll call this angle A, if we know angle A, right, then our opposite is going to be side A, okay? It's opposite from that angle that we know. Okay? We also have an adjacent side. Okay, do you guys know where the adjacent side goes?
On the bottom.
On the bottom, yeah,
BS.
where B is. And the reason for that is the adjacent side attaches the angle that we know to the right angle. Okay? It's adjacent, so it attaches the angle that we know to the right angle. Is that okay? Okay, and then what have I left out? What's last? What do we call C?
Yeah.
Hypotenuse?
The hypotenuse, yeah, for sure. So this is the hypotenuse. Okay, and the hypotenuse is always on the across from the right angle. Okay, and the hypotenuse is also the longest side of a right angle triangle. Okay, so now that we know our opposite and our hypotenuse and our adjacent, I will finish off our SOHCAHTOA. So for the first one is so. So sine is equal to the opposite over the hypotenuse. So. Next one is ka. So this is going to be cosine if we know the adjacent and we know the hypotenuse. Okay, so ka. And then lastly we have toa. So the tangent is equal to the opposite over the adjacent. Okay, SOHCAHTOA. We should know these. That SOHCAHTOA should be burned in your head. Okay, any questions so far?
Wait, so what is, sorry, can you go over what C, or S, C, and T stand for?
Yep, okay, so can I actually just show you with an example?
Mm-hmm.
Okay, but yeah, so like if we know the opposite side and we know the hypotenuse, then we're going to use the sine to find like the degree of our angle.
Yeah.
Like that's just going to be the function we're going to use. If we know the adjacent and the hypotenuse, then we're going to use cosine. Okay, and if we know the opposite and the adjacent, then we're going to use tangent.
Okay.
Okay, and those are just like the three different buttons that you guys have on your calculator, right? You'll see it, sine, cos, tan are right beside them. Right. And we'll get into some examples right away here, okay? So just believe me for now. Okay, so let's find the missing side lengths. So just the side lengths we're concerned about. So what are we going to use here? What theorem?
Tangent.
No, okay, because we're just looking for side lengths, right?
A squared plus B squared.
Oh.
Yeah, we want to use Pythagorean theorem here.
Yeah.
Yeah, so a squared plus b squared is equal to c squared. Cody, yeah, to answer your question, if we wanted to find the angles,
Yeah.
that's when we would use our like sine, cosine, and tangent.
Yeah.
Yeah, good question, okay? But yeah, so when we're just looking for side lengths, we can just use the Pythagorean theorem. Okay? And so let's start on this one where we have a 5 and a 7. Okay? What letter is my hypotenuse? C, right? Okay, good. So C is here, and then like I mentioned, I don't really care what you say A or B is. Okay? So A squared plus B squared is equal to C squared. How will we get C, because we're solving for C, right?
Yeah.
How are we going to get C all by itself?
Square root.
Yeah, we're going to take the square root of both
Is
sides.
it not by itself already though?
Well, it kind of is, but
Not
it has the squared,
we
right?
get rid of it.
We just want to find C. We don't want to find C squared, right? Are you okay?
Yeah.
Yeah? Okay, good. So yeah, once you take the square root of something, the square and the square root cancel.
So now it's just A squared plus B squared equals C.
So C is equal to the square root of A squared plus B squared. Okay? That's all good?
Yeah.
Okay, so then put this into your calculator. So when you do it into your calculator, you can do this all in one step, and it's probably a little bit easier that way, okay? So when you enter this into your calculator, press the square root button, Okay? Open up a bracket, put in your a value, so 5 squared, close your bracket, plus your b value, which is 7. And then in your calculator, it automatically opens up a bracket at the beginning, right? So just throw another bracket at the end of it, just to close that up. And then if you hit enter, you can do that all in one step.
8.6.
What happened?
And yeah, 8.6 for sure.
It said error.
So you probably were not careful with your brackets.
I put the bracket just how I did it. Oh, did I have to put another one?
Yeah.
Oh,
Yeah.
okay.
So when you press the square root button, it automatically goes up like this, right? Like this. Right? So it automatically goes like that. So then you need to do 5 squared plus 7 squared. And then close your bracket at the end of it, right? Okay, brackets are our friend.
Yeah.
Okay? Alright. So we get 8.6 for that. We're Brody, you were good for that?
Yeah.
You got 8.6? Okay. Cool. Yeah, awesome. And if you're done, or if you're moving on, just keep on cruising, okay? Okay, so we'll move on to the second one here. So this 9 is what side? Is, yeah, C, it's our hypotenuse, right? And then again, A and B doesn't really matter. But we need to solve for B now, right? So how am I going to get my B all by itself?
Subtract b squared.
No.
Divide.
We want to get B by itself, right? So, and B is positive.
Add a or no?
It's a positive A, right?
Subtract a.
Subtract A, good. Subtract A squared from both sides. Is B by itself yet? It's close, right? What do we need to do? Square root it, yeah, for sure. Okay, so then you'll get B is equal to the square root of C squared minus A squared. C squared, so 9 squared minus 6.5 squared. And then you should get a B value
6.5 squared.
6.2.
And you went 9 squared. What on earth did I do wrong?
I don't know, what did you do?
Always go with the third decimal place. So.
I got 6.5 squared, which was 42.25.
Yeah.
And I got 9 squared, which was 81.
Mm-hmm.
And then I put those together and square rooted that.
So you should have subtracted, right? It should have been 81 minus 42. And then take the square root of that.
It was a squared plus c squared.
Nope.
Oh, it was. Oh no, because I moved it to the wrong side.
Yeah. So just be careful with your when you're isolating, right?
No,
Be careful when you're isolating.
81.
You're good?
Yep.
Okay. Okay. Okay, so now we're going to use our trigonometry ratios. So this is SOHCAHTOA.
We missed one.
Oh yeah.
Oh. You guys can do that one on your own right now. Okay, so we can use trig ratios to solve the missing angles. Okay, so for this first example, we're concerned with angle x. So what is the relationship of 5 and 7 to angle x? What is 5?
That's
5 is
adjacent.
No, opposite.
Opposite, right? It's a
Seven.
cross.
Oh yeah, I know this one's yeah.
It's a cross.
And then the
From the
7
angle.
is the adjacent.
Yeah, for sure.
So we would use TOA.
You would use TOA.
Yeah, we sure would use
TOA.
TOA. Okay, good. So we're going to use TOA. Yeah, so tan is equal to opposite over adjacent. Okay, so and
So
really
we just
what
put tan.
it's really no. Okay, so it says tan of theta, so our degree, right? This is just saying our degree is equal to the ratio of opposite over adjacent. Okay? So that's what we're doing here. Now, to actually solve for theta, we need to take the tan inverse.
I don't know where that is.
It's just the second tan. Yeah, it's the same button, but you just press second, okay? So to isolate for theta here, you take the tan inverse, so tan minus 1, okay? So if you take the tan inverse of each side, okay, so tan inverse and tan, then you'll be left with theta is equal to tan, so tan inverse of the opposite side, which is 5, over the adjacent, which is 7.
So second
Second tan, 5 divided by 7.
Yeah, second tan, 5 divided by 7.
I was
Exactly.
Just I got the wrong answer.
Yep, just like that. Oh,
I got
and
0.6.
brackets.
and brackets, and you also need to make sure you are in degree mode.
How do you
How do you
So
change
go, so
Where's
you have mode right at the top here. Okay, press mode,
And go to
right,
degree.
and then go down and make sure you're on the degree. Yeah.
Okay.
Okay, and then you go second tan, 5 divided by
Oh,
7.
I'm on degree.
Close your bracket when you're done.
I don't know how I still got 0.6.
You,
Tan inverse, 5 divided by 7.
what'd
Yeah.
you get?
You're in radio.
What? It said oh.
Now you're in degree.
Logan, are you good with that?
No,
I
I-
know.
Just stop, Ruby. Seriously.
Apologies, Cody.
Good. Yep.
I'll give it
Okay, so then you get a theta of 35.5
The
degrees.
square root of that.
So, no, that's it. That's our answer. Okay, so you can.
Oh yeah, we're solving for never mind.
So 36 degrees is when you are giving me an angle, okay, 2 digits is fine. Okay, so just round it up so it has 2 digits. But if you also say 35.5 degrees, that's okay too. But if you want to clean it up and just give me a whole degree, that's fine too. Okay, so that's that. So let's look at this one right here. What is so with respect to angle X, what is my 6.5 and what is my 9? Yeah. Perfect. So my hypotenuse is always across from the right angle, and the adjacent is the side which connects my angle to the right angle.
Is it like the same, like punching it the same way in your calculator for like, cause
So what one do you want to use here, Brody?
CA.
We want to use ka, right? Yeah. And then yeah, exactly.
Sine.
You would just use second cosine.
43.76 degrees.
Cosine of theta is equal to adjacent over the hypotenuse. So theta is equal to cosine inverse of the adjacent, which is 6.5, divided by the hypotenuse, which is 9. Punch that into your calculator. What do we get?
44.
44 degrees? Cody, you too?
Yeah, yeah. I don't know why I put 43.7, but
yeah.
Oh yeah,
Well,
yeah.
you rounded up.
And we rounded it up, right? So yeah, Cody, if you like saying 43.7 degrees,
yeah.
that is totally fine. That is totally fine with me. Okay, try the next one on your own, please.
Question of finance beauty.
guys doing now? Good.
35.7. Oh, 36. So I'm a beauty then? Is that what that means? Is that what that means? Someone say it.
Just go.
Ooh.
Backwards.
Kind of. So in this cases, we know our angle, right? So that's nice. We know our angle. And so now we're looking for x, right? What is the relationship of x with respect to our angle that we know?
That it's cosine
Why?
because you got the adjacent.
Which one is my
No wait,
adjacent?
no wait. Hold on. It's 10. Because you got the adjacent and the opposite.
And this here is my opposite, right?
Yeah.
Yeah. Whatever is opposite from the angle given is the opposite, right? And the side length that attaches the angle to the right angle is our adjacent. Okay? And yeah, so we know opposite and adjacent, so we will use TOA.
Are we still using the second?
No, not for this one. Okay, so we
Could I
know
just, like,
10 is equal to opposite over adjacent.
Do you use a negative number? That sounds familiar.
No, you do not do that
So
either.
you just
Just stick with
do I just take
Yeah, pretty.
so I go like
No, I'm just kidding. You're pretty.
the tan divided by the adjacent to get opposite.
Close. Okay, so we know our degree in this time, right? So we know tan of 42 is equal to opposite, which we don't know, over the adjacent, which is 14.5.
No wait, times
Yep, exactly. And how are we going to get that opposite by itself?
times 14.5.
Perfect. Multiply both sides by 14.5.
13.
What?
And then you get an opposite side of...
Nice.
13.
Wait, what?
I probably did it wrong.
So you take
No,
your,
you just
so you take your opposite.
I
I
got-
used tan.
Oh.
You used tan 42 times.
Oh,
Yeah.
I just
So literally, so you're going to do tan 42 multiplied by 14.5 is what you're going to do into your calculator.
okay.
2.6.
13.1.
I think I did it wrong. Do you have to go
Let's see.
negative 10 too?
Nope, just regular tan. So tan
Tan.
42,
42.
close your bracket.
And then 14.5.
Yep. Oh, well, you gotta be better with your brackets.
Yeah, I messed up my bracket here.
You could just do, yeah, tan, and then you don't,
Bracket.
and then you don't even need another bracket after that. You can just put in 14.5.
Too late now. There we go.
There you go. Good? Good. Okay, moving on to the next one. So our angle is 37 degrees. So what is my relationship for x to 37 degrees?
What's
It's x is the opposite.
opposite?
Perfect.
Let's say it after I say it.
Is it
And-
okay if I have extra?
What is the 19?
It's
Hypotenuse.
Or just have like extra?
Sure, yes. And then you could just be like, this is for shoes.
Fine.
Or whatever, right?
You don't even
And the 19 was the hypotenuse, right?
Yeah.
Okay, so what ratio are we going to use? So, ka, or toa?
So
Yep, perfect. So we'll use so. We know so sine of 37 is equal to the opposite over 19, which is our hypotenuse. So we'll multiply by 19 to isolate for the opposite.
and then 19. 11.11. Just 11. Well, 11.4.
11.4 is what I got.
I just put 11. Is that fine?
Yeah, technically, you should give 11, right? Because we're given 2 digits and 2 digits, right? So technically 2 digits would be the correct one. Okay, try these next two one on your
Do the third one.
I'm
own.
already done.
You're already done. Well, no rush. We know angle 55, right?
Mm-hmm.
So what is my relationships?
AJ.
Yeah, we know the adjacent is right here. And our hypotenuse is over here. So we want to use cosine. Okay, so cosine
15 right or something?
of 55 is equal, so ka, so is equal to the adjacent over the hypotenuse. We do not know the hypotenuse, right? So we need to isolate for the hypotenuse. So I think this is where you may have gone.
I got, did you get 5 point something?
Yeah.
Yeah, so we need to multiply both sides by the hypotenuse. Okay, but we are isolating for the hypotenuse. So what must we do now?
Divide by the hypotenuse.
No, we're isolating the hypotenuse.
Or divide by the total.
Yeah, so we'll divide by cosine.
That's right.
Okay, so now we get hypotenuse
8.5 divided by.
is equal to the adjacent, which is 8.75,
Oh,
divided by cos 55.
we're at 15.
Yeah, that sounds much better. And yeah, one way, like we should always look at our answer and ask ourselves, does it make sense, right?
Yeah, well, if it's smaller than your A or B, you know it's wrong.
Exactly, yeah. If the hypotenuse is not the longest side in your triangle, you have done something wrong. Okay?
Now, do these look right now?
Yes. Yes. Okay, so with respect to the angle that we know, 24 degrees, what is 27.9 and what is my x?
Or is it minus opposite? And
Yep.
adjacent?
Perfect. So we have opposite and we have adjacent. So what do we want to use, Cody?
If you have opposite and adjacent, you want to use sine.
No?
What?
Tell.
Opposite.
Opposite and adjacent.
So katoa.
That's, I'm just retarded and I put,
No,
I
you're
put
not.
O,
Don't
I
use that
put
word.
O and A.
Oa. So katoa. Okay, so tan 24 is equal to opposite over adjacent. So is equal to, well, opposite over adjacent. We're isolating for adjacent. So multiply both sides by adjacent.
12.4,
Uh,
62.
which seems very wrong.
It is very wrong.
Wait, I had tan 24.
divide by tan 24, right?
Yeah.
So we got adjacent is equal to opposite, which is 27.9,
Yeah.
divided by tan
I got
24.
6.
I put 62.
I got 62.7 as well. 27.9 divided by
10.
tan of,
25.
yeah, but we have tan of 24.
What?
62.6.
Oh my god.
Yeah, 62.7 if you're rounding to 3 digits, right? Yeah, because 62.6,
Yeah.
number beside that is larger. Okay, so then we got, yeah, so adjacent is equal to 62.7 or 63. If you are rounding it though, you need to know how to round. Okay, if you make a rounding mistake, I'm taking off half a mark.
Okay.
Because rounding is grade 7 math.
I might ask you a few times if I'm rounding right now.
I also almost failed to tell you after.
Okay, last one here. So try this one on your own, please.
Triangle on the left.
For what?
Yeah, you gotta find that one.
What do you mean? We're looking for this.
You were getting there.
Yeah. That's what I
Yeah,
had.
what
We're
I'm
getting
doing,
there.
what I'm
We're getting
doing
there,
is
yeah.
I'm gonna find like the one in the middle, and then I'm gonna find B.
Good. That's exactly what you need to do.
Yeah.
Because it shares a side length, right?
Mm-hmm.
And then, okay, yeah, so for this, for triangle ABC, this is the opposite, right?
Does 96 sound right for the opposite?
You know how you're done. No.
Yeah, that sounds about right.
'Cause that's what I got.
Yep, yeah, 96. Oh, okay. When you guys are doing like a two-step problem, such as this,
Mhm.
okay, you do not round your opposite, or like,
Oh, we don't.
don't round it
So
until the very end.
95.5.
Like Logan, I'm okay if you say that this is 96, what you calculated, right?
Yeah, just don't
Um,
do that. Punch it
but when you use it to calculate your other number, do not round it, okay? Because you will get like not the most accurate answer, okay? Do not round your intermediates.
Okay.
Say this with me.
Do not round your intermediates.
Okay. I will not round my intermediates. Okay, ready, boys? I will not round my intermediates. Cody?
Probably won't round my intermediate.
You will not round your intermediates, okay? So this is the opposite on this side for sure. For
Is it
ABC.
100 Is it 152?
Nope.
So that's bigger than your hypotenuse.
Is that
Okay.
what you got too?
So what
No.
side is this in triangle ABD?
The hypotenuse is.
It is the hypotenuse. Good.
Is it 60.4?
No. What are you doing?
Shit.
Where are you?
Okay, so I had 96
You
here.
got 96. Well,
And-
95.512.
Okay.
Right?
And I had 51 here.
Mm-hmm.
So I had my hypotenuse and I had my adjacent. So I went cosine 51.
Okay, but you should have done your sine, because this is your, on this side of the triangle, this is your hypotenuse, right?
Yeah.
And this is your opposite.
Does this sound right?
Yeah.
74.22, like 7.
Yes,
Okay.
74.2 is the answer.
Oh, I had 8 and I went, okay, wait. So I had, so it's sine 51.
Okay, so just to
Great.
summarize, so for the first step, we had tan of 48 is equal to opposite
What'd you get?
over 86.
What'd you get?
74.
70.
So then we get opposite equal to 95.5 decimals, okay, I'm not rounding, right? And then for the second part, for the blue part, we know our hypotenuse is 96, or 95.5, right?
Yeah.
So hypotenuse equal to 95.5, dot. So sine of 51 is equal to opposite over the 95.5 dot, right? And then you get an opposite for that equal to 74.2.
Yoink. I
Okay.
got 74.6, but
And did you round your intermediate?
no.
Are you sure?
Yeah.
Okay, well I did.
No, I just had this is supposed to be 95.5 or whatever, and 96.
Yeah. See, and just like the small thing, right? It'll be off by a little.
that right?
Huh?
If you showed all your work and I
0.4.
saw that, I would take off half a mark for rounding your intermediates.
Yeah. Shame.
That's just mean.
All right. I have a worksheet for you guys to work on now for the remainder of class. And then tomorrow we will do the sign law, okay?